Okay, everyone. Hopefully midterm two was not too bad. If it was, let's set up a time to talk. We'll figure it out. I promise you, you will figure it out. Let's just work together. Um, we're now going to start midterm, the final third of the class. We're going to talk about monopolies today. We'll briefly mention monopsonies, but they're not as important as monopolies. Because how many markets do you know that you're the only person that buys something? So we're not going to talk a ton about those, but we'll briefly mention them. So yeah, let's just jump in. There's no reason to keep these long. So in this section, we're going to cover seven main topics. Monopoly profit maximization. So like all firms, a monopoly maximizes its profits by setting its price now or output so that its marginal revenue equals its marginal cost. But in a monopoly, since it's the only one there, it can choose what prices it takes. And monopolies in the United States are a little weird. Like Google could be considered a monopoly. Apple could be considered a monopoly. Facebook could be considered a monopoly. Amazon, Microsoft, almost all um, utility companies could be considered a monopoly, all sorts of things. Also, not sure why that one is so much larger than the rest of the numbers, but that's okay. Then we're going to talk a little bit about market power and welfare. So, how much the monopoly's price is above its marginal cost depends on the shape of the demand curve that the monopoly faces, and this gap lowers welfare relative to the competitive level. We're going to talk about taxes in monopolies, so specific ad valorem taxes to increase deadweight loss may have consumer incidences over $1,000 and affect welfare differently from each other. Causes of monopolies, one would be like a firm's cost advantage over other and potential government actions. And then government actions that reduce market power, they can regulate the price of monopoly charges or allow other firms to enter the market to eliminate the welfare loss. Then we're also going to talk about some internet monopolies. So there's some network externalities and economies of scale that facilitate internet monopolies. Those are a little weird though. We're not going to spend like pretty much any time on that. And then again, monopsonies, they're cool. They're the opposite side of a monopoly, but we're also not really going to focus on them a ton. It's a single buyer that maximizes its profit by paying a price below the competitive level. So the welfare is lower on the buyer side as well. But again, we're not really going to talk about those. This chapter, we're going to really be focusing on just a little bit of things. I only think that there are going to be two videos in this section. So yeah, let's just get started with this first one. So the first one, let's talk about monopoly price maximization. Um, so when we're thinking about monopoly price maximization, a monopoly is the only supplier of a good for which there are no close substitutes. So look at this really blurry picture that I am not sure why it's so blurry. But in perfect competition, you have these marginal costs. So this marginal cost curve here, if I could draw, and then you have this average cost. And then we know that the price is equal to the marginal revenue because they're price takers. So the price line is horizontal. But in the monopoly, the average revenue declines and the marginal revenue declines. And our marginal cost and our average cost curves remain the same. But if we notice that because our marginal revenue and our average revenue are different, it creates multiple equilibria that allow these prices to be set at different levels. So the C is competitive. This would be the price that a monopolist would set. And so we are actually going to be generating a lot of deadweight loss when we're doing something like this. And we should remember a little bit about deadweight loss from principles, but if we need to run back over that, I can post a short little follow-up video. And so when we're comparing this monopoly, we're always going to be using perfect competition as our reference point. So our monopoly demand in this market is going to be the market demand because we're only dealing with one firm. So we're only dealing with one institution. They are the market. They have 100% of the market share. And so there's really nothing that they can do, or I mean, the market can do to adjust its price or quantity to generate additional welfare for individuals. Monopolists can set their price given market demand. They are now the price makers. And so monopolists will typically set their price greater than their marginal cost to maximize profit. So if we come back up here, this price here is going to be set here, which is above its marginal cost. And so um, it's going to maximize that profit. And so monopolists maximize profits by setting output so that their marginal revenues are equal to their marginal costs. And so this output here is when this marginal revenue is equal to this marginal cost. And so that is going to be the output rather than the price. That's going to set the output as well. But our marginal revenue curve is going to change. That's going to be the key driving factor here. And so when we're dealing with profit maximization in this instance, or underneath a monopoly is going to choose its optimal output Q star. And the necessary condition for profit maximization is that marginal revenues still need to equal marginal costs, right? So this statement here is the same as perfect competition. So your marginal revenues are going to be equal to your marginal costs. The difference is that our revenue functions are going to look slightly different. But a sufficient condition for profit maximization here is that this second derivative needs to be zero. And if we remember from calculus, when we're dealing with this, all this says is that this is going to be a maximum, not a minimum. So at the optimal quantity Q star, the slope of the marginal revenue needs to be less than the slope of the marginal cost curve for profit maximization. So if we come back up here and we're thinking about this, is this slope on this marginal revenue curve, right? This is a negative slope. And at our optimal, this slope of this marginal cost curve, which is kind of a weird thing to think about because we're dealing with slopes of curves that are slopes of a curve, right? So when we think about the slope of this marginal cost curve, this is positive, and so both of those terms here would make a maximum because the slope of this marginal cost, this marginal revenue is negative, and this was positive, and so it would be less than zero. And so when we start to think about a little bit more, and let's dive a little bit deeper into marginal revenue here, a firm's marginal revenue depends on its demand curve, right? And so for our perfect competition, the marginal revenue was flat, right? Our marginal revenue was equal to our average revenue, which was equal to the price. I know we're bouncing back and forth up here a lot, right? But to remind ourselves, that's this line here, right, is that this price is equal to its marginal revenue, is equal to its average revenue, and it's going to be a flat line. For a monopoly, our marginal revenue is downward sloping and lies below typically the demand curve. And so when we come back up here, we're going to see that this average we could think about this average revenue as the demand curve. Or something along those lines. But this marginal revenue is going to be less than all of that. Don't think about the average revenue as a demand in theory, but if we just like pretended that we erased this and that was demand, it would be that way. And so we would be below the demand curve, and that would be fine. And so this marginal revenue for a monopoly is downward sloping, lies below the demand curve. That means that the price be the inverse of the demand function. And so our revenue, P of Q times Q, leads to a little bit of interesting situations. So if we have this marginal revenue is equal to dr dq, um, then this would be the same thing as saying PQ times Q dq. And so this would be PQ dq dq plus dpq dq times q. Or this is just 1. And so this is going to be P of Q plus dpq dq over q. And this is our marginal revenue as it varies. So if we think about this a little bit more, right? So we're going to take that result that we just had. Here, price is equal to our average revenue, which is the inverse demand curve, but dp dq is the slope of the inverse demand curve. So this part would be the slope of the inverse demand curve. So we proved that the marginal revenue lies below the demand curve because this demand curve must be added. There must be an additional price set to this so that the marginal revenue can reach up to that point. And so without that additional price factor, we wouldn't have the same thing. And so marginal revenue is less than our price is equal to our AR, our average revenue. And so a graphical illustration of this, right? So suppose that we had our initial revenue was this P1 star times Q. So this combination here, right? If we sell one more unit, right, then our demand curve means that we have to sell it at price P2, right? So now our new combination is that combination. And so we get to add, so our initial revenue, R1, is equal to A plus C because it's going to be the area in that box. Our new R2 is going to be A plus B. Our marginal revenue is now B minus C, right? Because we are losing this C, but we are gaining this B, right? And so that would be the benefit of moving from Q to Q1. But remember, we also have to shift down this way. We have to lower our price. And so the B area would be like the benefit of that we get from selling an additional unit, and the C would be the like cost that we have to incur because we're going to have to charge less now. And so B, the area of B, is going to be P2 times 1, right? So this area here is just going to be P2, right? If we think about this, this length here is just P2, and this is going from Q to Q plus 1, and so this definitionally has to be 1. So B is going to be equal to P2. So our marginal revenue is equal to P2 minus the area C. And so our marginal revenue is less than the price it charges, right? By an area amount, an amount equal to the area C. So coming back up here, right? This marginal revenue has to be less than our revenue, like the average revenue that we are generating, right? Perfect. So our marginal revenue, and we'll look at this from a price elasticity component, um, is going to be slightly similar, right? So for our inverse demand function, we're going to have P of Q is equal to 24 minus Q, right? And so that is going to be this blue line here. So we're going to write blue next to this. And then we will have the purple line will be the marginal revenue. So when the demand curve hits the price axis, our quantity is equal to 0, and so the demand curve is perfectly elastic. So our marginal revenues will equal our price, right? So purple is equal to 24, right? Which is exactly what our price is. At the midpoint, when we have epsilon, var epsilon is equal to -1, notice that that is when our marginal revenue equals 0, or when the quantity that our marginal revenue would equal 0 at. So when the demand curve hits the quantity axis at P equals 0, the demand curve is perfectly inelastic here. However, we would be perfectly inelastic on the marginal revenue curve as well. So the monopolist will never produce on the inelastic part of this demand, right? So if we were to cut this, right, when our marginal revenues go below 0, we just are going to stop producing. And so we will never be producing on this portion of the revenue curve. And so we are only going to be looking at when the marginal revenue is. So we will never produce on the inelastic part of the demand as our marginal revenue is less than 0. So when we are at epsilon equals 1, we would be like, we would call it at unity. And so we will be perfectly fine. I mean, we won't be, a monopolist will never produce an inelastic good. So if we wanted to show this mathematically, right, let's say that our marginal revenue is this function again. We showed it up above. I can scroll back up if we need it. But if we first multiply and divide by P on the second term, right? So let's take this. Let's take our marginal revenue is equal to P plus dP, dQ. I'm going to throw this Q over 1, and then let's multiply by P over P. So if we remember, our epsilon was our dP dQ times Q over P. And so our marginal revenue now can be written as P plus epsilon, epsilon P. Or Sorry, no, this is backwards. This is backwards. That's why I'm thinking this is backwards. This should be dq dp times p over q. Um, and so we will then have p plus p over epsilon, right? If we can rewrite this here as dp dq times q over p times p. And so this looks super similar to that. It would just be 1 over epsilon. And so we will just have p plus 1 over epsilon times p, which we will throw right there. And so we'll just throw. So our marginal revenue now, factoring out a p, should be 1 over 1 plus the elasticity of demand. So there's a couple things here. One, demand is perfectly elastic when marginal revenue is equal to price because it implies that epsilon tends to infinity, right? It means that this term in green would need to go to zero, which happens when epsilon tends to infinity. Demand is unit elastic or at unity when our marginal revenue is equal to zero because epsilon is equal to -1. And then we would also say that demand is perfectly inelastic when our marginal revenues are less than zero because epsilon has to be zero. It would cause this term to go to negative infinity, to positive infinity. Yeah, that should work. That should work. And we can see that graphically up here as well. Okay, so let's think about an example. If our inverse demand function is P equals 320 minus 2Q, first let's find our marginal revenue, right? So our marginal revenue, um, if we are thinking about P is equal to 320 minus Q, right? What do we need to do to find our marginal revenue? Let's think about this for a little bit. What do we need to do when we're finding our marginal revenue? Well, let's come back up here and see what happens. Our marginal revenue is equal to P plus dP dQ times Q, right? So if we wanted to think about this, we would get marginal revenue is equal to P plus dP dQ times Q, right? And so we know what P is. That's 320 minus 2Q plus dP dQ is minus 2. So we're going to go minus 2 times Q. And so our marginal revenue would be 320 minus 4Q. So now, if we were drawing this, we would have 320 price, quantity, and at this would occur at 160. So this would be our demand. We're just going to call it D. Now our marginal revenue curve also is going to have 320, but it is going to intersect this x-axis at a much lower level, something like 80. Let's call this our marginal revenue. And so at quantity 80, our marginal revenue is equal to zero. So marginal revenue is equal to zero when Q is equal to 80, and that is going to correspond to a price equal to 160. This would also be the price elasticity of demand is equal to zero. I mean, is equal to one. So sorry. Unit elastic, or is equal to -1. Unit elastic. It's going to be at this point here. Oops. It's going to be at this point here. So yeah, that would be an example of one question that you may see on the homework. Let's do another one, right? So we've got now an inverse demand and an inverse cost function. Um, when we have an inverse demand function and an inverse cost, we can find the profit maximizing output by setting our marginal revenue equal to our marginal cost. And so if we remember, our marginal revenue is given by P plus dP dQ times Q. So our marginal revenue would be equal to 24 minus Q plus -1 times Q, or 24 minus 2Q. Our marginal cost curve is just 2Q. So setting marginal revenue is equal to marginal cost would give us 24 minus 2Q should equal 2Q. So Q star should be 24 divided by 4, which is 6. And so then our market price would be P should equal 24 minus 6, or 18. And our profit, if we remember, our revenues should equal price minus our average total cost times the quantity. So let's take this as 18 minus our total costs of producing at 6 was 36 plus 12, which should equal 48. Divide that by 6 is 8. So 8 over, oh, that was 8, sorry, times quantity demanded. Sorry, that's not quantity demanded. This should be quantity demanded, which should give us 60, right? 18 minus 8 is 10, times 6 is 60. So, looking at this same example, right, we said that the marginal revenue should equal marginal cost when quantity demanded is equal to 6, right? That is exactly true. That's what we said here, and it corresponds to a price of 12. Um, Oh, no, sorry. That's not the price that it corresponds to, because the price that it needs to I mean, the market price, I guess this would be the equilibrium price, but the market price we are going to charge is 18, right? Which would be up here at this E. Um, and so then our total profit, which is what we said was 60, is going to be the area in yellow here, which would be 60 as well. So let's look at a shutdown decision example then. So our monopoly shuts down if our monopolist's price is less than our average variable cost, right? So if we come back up here, it would be when this term goes negative. Um, and if we're thinking about when that term goes negative, that would cause our revenues to go zero. I mean, to go negative as well. I mean, our profits to go negative as well. So in the last example, our AVC was 6 and our price was 18. Or sorry, this was average total cost. This was not average variable costs. I apologize. This should be a little bit higher. I mean, it should be close to that though, but our average variable cost was 6 and our price was equal to 18. So in the short run, we should not shut down. Going back going back to this example, right? So let's come back or something similar. Let's go back to P is equal to 100 minus 2Q and C is equal to 30 plus 6Q. Let's do all of these questions. So first, let's find the optimal Q and P. Let's draw our demand and marginal revenue choice, and its choice is Q star and P star. Let's find the profit, and then what happens if fixed costs increase by 70 to all of the things that we do. So first, let's figure out what the optimal values are. So remember, our optimal values are going to be when our marginal revenue, which is P plus DQ star, or DP DQ, so sorry, times Q, which should equal 100 minus 2Q plus minus 2 times Q, which should equal 100 minus 4Q. Our marginal costs should equal 6. So we are going to get 100. What? 100 minus 4Q should equal 6. 94 should equal 4Q. Q star should equal 23 and a half. I think that sounds about right. If we throw 23 and a half back into here, we are going to get that P star should equal 53. So we throw this on a graph. We're going to draw it big. We are going to then say that here, price, quantity, 100, boop, 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 50. Our marginal rev, so this was demand. Our marginal revenue also starts at 100, but then it is going to cross down here at 25. So that would be marginal revenue and marginal demand. And then our choice is going to be at 23 and a half. Is that what we said? So if we come back up here and see how this is supposed to look, if we were going to be able to show like our marginal cost curve, I mean, I guess we could show our marginal cost curve. So our marginal cost curve is just 6, right? So if we said, um, regardless of the Q, it's just going to be at 6. So this would be marginal revenues. This would be marginal costs. These intersect at 23.5, right, which is exactly what we see up here, that marginal revenues and marginal cost would set the quantity. And then at this, it's also going to show the price that we can set, 53. So then our profit, and if we remember, our profit is equal to is equal to P minus ATC times Q, right? If we come back up here to this is an equation that you guys should probably jot down. Let me change this R to a pi though. So we have pi should equal 53 minus 30 plus 6 times 23.5. All of this divided by 23.5 should be 30 plus 6 times 23.5 should be like 7.27 times our quantity, which is 23.5. This is going to give us like a profit of 1074.50. So it would be, remember, It would be if there was an average cost curve. I think it would be this box. Um, well, almost that box. There's going to be another line. It'll probably slope like this. It'll be our average cost curve. And this line here is going to be 7.27. So if we drew a dashed line from there, it would be this box. We're going to highlight this box. So now suppose that $70 increases, right? So now suppose that this $30 increases by 70. Nothing will change to Q and P, but it will raise our profits by 70. So our average total costs will now look something like this. Sorry, I don't know why it keeps snapping into this. Here, we'll just AC. And so now we're going to have this new P, A, we're going to have this new second price here. And this is going to cause it to drop. This is going to cause profits to drop by $70, right? Because this term here is going to have another 70 plus 23.5. It's going to cancel with this 23.5, and we're going to see it fall by $70. And so that's the end of this first video. Now we're going to jump into video 2. Thanks.